Ooh, spooky, spooky, ladies and gentlemen. The case of the missing diagram. So you are going to be tested when not given a diagram for a proof. You have to create the diagram, create the given and the proof, and then prove it from maybe a statement of some kind or a theorem. So we're going to practice with that right now. It is rather challenging, but you are going to get it. I believe in you. So here's the situation. Given a statement, an if-then statement, hopefully properly written. This one is not. No, it's properly written. All right, so it says, if the line joining a pair of opposite vertices of a four-sided polygon bisects both angles, then the remaining two angles are congruent. What the heck? Okay. Now this one's a little bit more involved than some of them. It's definitely a little bit more difficult, but we'll work through it together. So first thing I want to do is I want to draw a picture, and I'm going to move this way out of the way so I got room to work, all right? So if I draw myself a nice picture, I've got a four-sided polygon. I'm going to draw it kind of like a parallelogram, which we don't officially know what that is yet. That was pretty terrible. I'm going to try that again. That's a little better. And I'm going to label each one of these. Yeah, we don't know what a parallelogram is officially, but we will soon. Oops. Okay. And it says the line joining a pair of opposite vertices. So there's a line joining a pair of opposite vertices. Saying that it bisects those two angles, and we want to prove that the remaining two are congruent. So basically we have in our given quadrilateral, quad A, B, C, D, and we go around clockwise or counterclockwise. We wouldn't go A, B, D, C. That wouldn't make sense. We're saying that DB, ray DB, bisects angle ADC, and ray BD bisects angle ABC. So we align joining the pair of opposite vertices of a four-sided polygon bisects both angles, so it's bisecting both the angles, and the remaining two angles are congruent. So my proof, I'm already at my proof. My proof is angle A is congruent to angle C. Those are the remaining two angles, all right? So I got my given, I've got my proof. I think we're ready to start this proof. So it takes a bit of like detective work to take out what you need from that statement. Drawing the diagram first helps, then writing your given and proof from that diagram so you can use like the actual like points, the letters for the points. That really helps. Okay, so let's prove this thing. Oops, not statement. There we go. So we got my given that I just wrote. And all right. Well, I'm thinking I want to prove those two triangles congruent so I can get A and C congruent from CPCTC, right? Really, this proof isn't too bad once it's all written up. The writing it up is the hard part. Well, if those two angles are being bisected, I'm going to label them as 1, 2, 3, and 4, make it a little easier. Angle 1 is congruent to angle 2. Angle 3 is congruent to angle 4 by the definition of bisect. And even though, and I'm running out of room, there we go, it works. Even though there are different angles that are being bisected, I can still use this in the same step because it's not like one getting bisected has any bearing on the other one getting bisected, okay? Alrighty, well what about, so I've got two angles. I need a pair of sides. I've got these two angles, I've got these two angles. I need a pair of sides. How about DB is congruent to itself? That'd be reflexive property. Do I have enough to prove these triangles congruent? Heck yeah. So triangle, it'd be ADB. Let's start with that. ADB is congruent to triangle. Well, what matches up with A? C, obviously, because we want to prove those two congruent. Then what matches up with D? Well, D would as well, actually, in this case. It's not really like flipped around like we've dealt with sometimes. CDB. So ADB, CDB, because D has angle 1 and 2, B has angles 3 and 4 for the vertex, right? So that's how I get those guys. Awesome. That's why I arrange it in that way. And that would be my angle, side angle. And lastly, but not leastly, I've got my prove. Angle A is congruent to angle C by CP, CTC, CP, CTC. Corresponding parts of congruent triangles are indeed congruent. I've got it done. I've got my 2 remaining angles congruent, much like that statement wanted. Woo-woo! First, scary, scary proof without a diagram. Actually, we've done it before. All right, here's your homework. 5, 6, 8, 9, and 13. Draw yourself a diagram. Write the given and prove. I would double check your given and your prove with the key and then try proving them. Okay? Wonderful. Excellent.